Trig lesson 5. This is important. Trig graphs. I need to introduce an entirely new type of graph to you. An entirely new type of graph. It's called a periodic function. And what's a periodic function? A periodic function is a function whose graph regularly repeats itself over some interval. The graph appears over and 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 over. And the length of this interval is called the period of the function. That's why we call this a periodic function. If you draw a line down the horizontal center of a periodic function, if you split it in half, we call that the midline. And the maximum vertical distance up or down from the midline that a graph travels is called the amplitude. By the way, in sound waves, amplitude is volume. I just used more amplitude. That's why something that makes a stereo louder is called a what? Amplifier. Okay? So, this is what I mean by a periodic function. Can you see the way it repeats? And it's going to keep doing this off the screen forever and ever and ever and ever. What would the period be? Well, the period is how long it takes before it starts to repeat. The easiest way to find the period, the easiest way is to go from peak to peak, or to go from valley to valley and just figure out that distance on the x-axis, because those are the easiest ones to spot. So, Jake, if I drop down, what's the x value right there?
10.
If I drop down, what's the x value right there?
2.
What's the period? How long is one graph? How long is one wave? 8. Okay, the period is 8. You'll also notice from bottom to bottom is 8, or from middle going down to middle going down is 8, or from middle going up to middle going up is 8. The only reason I don't use the middle ones is I might not notice that it's going down when it's going up. Peak and peak, bottom and bottom, Justin, those are the easiest to spot. Okay? What's the amplitude? What's the amplitude? In fact, you know what? We're going to use the letter A for amplitude. Nice abbreviation. Well, the midline is the line that splits the graph exactly in half. Foster, how high up do we go from the midline? 10. How far down do we go from the midline?
-10.
We would say the amplitude is 10. From the center, this graph goes up 10, returns, down 10, returns, up 10, returns, down 10, returns. It's periodic. There are in physics thousands of examples that are periodic functions. They show up all over the place. You guys with me? B. This is a periodic function. Don't write this down. It's going to do that forever. Domain would be all reals. It's going to go forever. Okay. What's the period? Six, and I also could have got it from bottom to bottom. Probably that would have been easier now that I think about it. What's the amplitude? Well, first, where's the midline? How high? 6. How high? -2. What's the total distance? What's the total vertical distance here? If they give me a yucky graph, here's the easiest way to find the midline. I find the total distance that it travels vertically. So how high? 6. How low? -2. What's the total distance that this graph travels vertically? 8. If the total vertical distance is 8, where would the midline be, from the top or from the bottom? Well, first of all, distance of 4, which means in this graph a height of 2. So the midline is right there. What's the amplitude? How high and how low does this graph go from the midline? Four. Hey, Jordan, what was the total vertical distance traveled?
8.
What was the amplitude?
4.
Jordan, what was the total vertical distance traveled in graph A? What was the amplitude?
9.
Can you see another clever way that I can find the amplitude? Or, you know what? Highest distance between top and bottom divided by 2. Is that okay? It turns out that sine and cosine and tangent are all periodic. And sine and cosine are very similar to each other. Tangent is not. It's the ugly cousin. I did my ugly cousin story with you a couple of days ago, right? Okay. So what does the sine graph look like? Well, let's find out. First of all, put your calculator in degrees. So if you haven't already, go Shift Setup, degrees. How did I know to go to degrees? Because of that and that. And I look at this chart here. It says, complete the following table of values. And what we're graphing is, instead of x, well, that's okay, sure. X is going to be in degrees, and our y value is going to be the sine of the x value. So I'm going to go sine of 0. What's the sine of 0? What's the sine of 30? What? Please type it. Go. Sine of 30. 0.5? Sine of 60. Sine of 60. 0.866. How about 0.87? Sine of 90. You're not doing shift. I'm giving you the angle. Right? Guys, all it is, sine of 90. I'm giving you the angle. 1. Sine of 120. 0.87. Sine of 150. 0.5. Sine of 180. 0. Sine of 210. Negative 0.5. Sine of 240. Oh. Negative 0.87. Sine of 270. Negative 1. Kyla, sine of 300. My way of saying shh. Sine of 300, folks? Negative 0.87. Sine of 330, hopefully negative 0.5. Sine of 360. Okay, let's graph this. So this is a graph that's going to go through the first point, 0, 0. We're going to put on the y-axis the sine value, the decimal. On the x-axis, the theta, the angle. So 0, 0. Now, looking at this graph, what angle is this right here? No, right here. Look, what angle is that right there? Look where what angle is that? 90. What's each square worth? How do you know? Because 3 squares make up 90. So, okay, so each square is worth 30. So this is 30 degrees. What do we get for 30 degrees? 0.5. Now, 1 is right here, and it looks like there's 1, 2, 3, 4, 5 squares apiece. So I guess 0.5 is going to be 2.5 squares up, right about there. What's the sine of 60? 0.87, well, 4 squares would be 0.8, so 0.87 right about there. What's the sine of 90? That one I can do. 1. What's the sine of 120? 0.87, about there. Sine of 150, 0.5, right about there. Sine of 180, 0. Okay, I'm just getting them right from here, and I've clued in each vertical square is worth 0.2. It goes 0.2, 0.4, 0.6, 0.8, 1, and each horizontal square is 30 degrees. So I can figure this out with reasonable accuracy. 210 degrees, negative 0.5, yoink, about there. Oh, I went too far. Uh, 240 degrees, looks like it's negative 0.87, yeah, about there. 270 degrees is definitely negative 1. And then I think it goes, I'm spotting a pattern, yes? Sine graph, it says plot the grids below, plot the point, don't join the points. Let's actually go to our graphing calculator. So let's go, thunk, menu, and then go to the graph menu, this one. I said graph, what would be a suitable window based on the above graph paper? Okay. It's X min, X max scale, Y min, Y max scale. Look at my graph paper. How far left does my graph paper go? Negative 360. How far right does my graph paper go, Rosanna? Thank you. I thought you were zoning out. What's each square worth horizontally? 30 degrees? How low does my graph go vertically? Just past negative, right there, which is negative 1 point what? Really? 5 squares make up 1. What's each square worth? 0.2. So negative 1.2. to positive 1.2. What's each square worth vertically? So first thing we're going to do is we're going to set up this view window. Our X min is going to be negative 360. Our X max is going to be 540. Scale every 30 degrees. I'll leave the dot thing as is. I never touch that. Our Y min is going to be negative 1.2. Y max is positive 1.2. Scale 0.2. Okay, I lifted that, Caitlin, right from the graph paper. What do I want to graph? Sine x. Make sure you use the x variable. Don't use that x there. And hit draw. What's the sine graph look like? You get that thing? Okay. This is a periodic function. And maybe not get that? Now's your chance to tell me. Christina, you got that okay? Yeah, yeah? Okay. This is a periodic function. It does this. Keeps going forever and ever and ever and ever and ever. So here is, we'll trace the points. One period. And this shape repeats. But I never graph it this way. Here is, I said to you, you can figure some of this out from your graphing calculator, but I said it's worth memorizing a few things. Can you go back to this chart? And can you put a little star right above the 0, above the 90, above the 180, below the 270, and below the 360. Those are the ones that I know. By the way, what we're really talking about in terms of our circle, we're talking about 0, 90, 180, 270, and 360. What's the sign of 0? What's the sign of 90? What's the sign of 180? 0? Okay. I memorize this. I know that at 360, it's 0. And at 0, it's 0. Write this down. How many degrees would right there be? 180. I also know that's 0. How many degrees would right there be? I know it's 1 high right there. How many degrees would right there be? 270. I know it's -1 high right there. As a graph, the sine graph looks like that. Not a great sketch because I kind of missed the 180, but it's a sketch. Should go through that 180. Fine, I see some of you staring. Draw it better than that. That's one period of the sine graph. By the way, turn your head sideways. What letter does the sine graph look like? S. Okay. It says complete the graph above. I'm not going to draw it all on here. We have it on our graphing calculators. We've only graphed between a domain of -360 to 540, but the graph goes forever. Sine has a domain of all reals. You can find the sign of -1 trillion. You can find the sign of +1 trillion. You'll get an answer. The sine graph goes up, down, up, down, up, down. So, state the following. Domain, what did I say the domain of sine is? All reals. Is that okay? Range, go look at the graph. What's the lowest it gets? It's really a nice number. Yeah, you do. What's the lowest it gets? It's a nice number. It shows up on your graph. -1. What's the highest it gets? Now, I'm going to ask you to memorize that range, and I'm going to suggest, boy, that's a nice, like it could have been yucky. The range is actually -1 less than or equal to y less than or equal to 1. Everything between -1 and +1. Touching and touching. Could have been an ugly range, but Kayvon, that's not bad. Plus or minus 1. What's the amplitude? What's the highest it gets? 1. What's the lowest it gets? 1. Total distance is 2. What's the amplitude then? Amplitude's 1 as well? Oh, I like this graph. This graph goes 1 up, 1 down, 1 up, 1 down. Period. How many degrees is one full wave? 360. Oh, once around the circle. That doesn't surprise me, actually. I can remember that. The period is once around the circle because that's how we generated the graph. So what's the period in degrees? By the way, you now know the period in radians. What would the period of sine x be in radians? 2 pi. Guys okay back there? X-intercepts. Where's the first one? Even before that, where's the very first one? Okay. 0 degrees, and then every how much after that? Looks like every 180. Another one, another one, another one, another. So how am I going to write that? I'm going to say 0 degrees plus 180 times, 180 degrees times n plus multiples of 180. Every 180 degrees. Every 180 degrees. Is that okay? Y-intercepts. 0, 0. That's the sine graph. Looks like a letter S. It starts out, first of all, has a period, Brooke, of 360 degrees, which means that's 180, that's 90, that's 270. And it breaks into 4 chunks. It goes, ready? Middle, top, middle, bottom. Middle, top, middle, bottom. Middle, top. There's the pattern. Next page. Oh. How would these values changed if we graphed in radians? Let's sketch y equals sine x, where x is in radians. Okay, we're not going to use a graphing calculator. We're going to do this by hand. What I want you to do is this. Draw a big, long, sideways graph. That should be a little better, Mr. Dueck. Okay. What's the period of sine in degrees? What did we just say? What's the period of sine in degrees? You may have to turn back one page. What did we just say? 360. What is it in radians? So you know what? Right here, dunk, put a little 2 pi. That's almost all you need to memorize. You can almost find everything else by being clever. Show you what I mean. What would that be? Think about it. Pi. What would that be? What would that be? Half a pi, which we call pi by 2. This one is a little bit trickier. What would that be right there? Oh, wait a minute. Look, 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 look. Look up, look up, look up, look up, look up. 1 pi by 2, 2 pi by 2s, 3 pi by 2. So there I can label my x-axis. If I know that 2 pi and 360 are the same thing, then I just divide it in half and then divide each half in half. Okay? What, guys, I need your attention here. Deal with the distraction. What's the highest sine gets?
1.
What's the lowest sine gets? What letter does sine look like sideways? So it's going to look like this. Watch. Put your pencil. Once you've got that written, put your pencils down and just watch. Starts out at 0, 0, and it goes up. Ready? Hey! Need your attention here, guys. This is nonsense. You're grade 12s. It's not squirrel. Need you here. Right? So, starts out at 0, 0. The next key point is this one. It's going to be 1 high because it goes top. Then it goes middle. Then it goes bottom. Then it goes middle. It's going to look like. And it's a smooth curve. Don't do it jagged. It's going to look like that. What's that you say, Foster? You'd like to draw one more period? Sure. I'll just lengthen this line a bit. What would I call yoink right there? Think about it. 4 pi. What would I call that right there then? Three pi? What would I call that right there? And that, you know what? I'm not going to label them, but here's what I know. It's going to go middle, top, middle, bottom, middle. Not the best sketch because my ones aren't quite the right height. I'm kind of freehanding Silka, but you see what we're getting at? It goes middle, top, middle, bottom, middle, top, middle, bottom, where the top is the top amplitude, 1. Fairly nice, easy number to remember. The bottom is the bottom amplitude, 1. Start in the middle, go up, that's sine. There's 2 periods of sine. Hey, I could even, with a bit of cleverness, go backwards in the negative direction. It wouldn't be that tough. In the negative direction, don't write this down, but it's going to look like that, right? There's sine. Again, domain, all reals. Range between -1 and +1, we write that as -1 less than or equal to y less than or equal to 1. The bottom is the lowest, touching. The top is the highest, touching. Y is in the middle. Amplitude, 1. Period, 2 pi. Oh, y-intercept is still 0, 0. And what about the x-intercepts? Colin, the x-intercept, the first one is still 0. But not, 180 is degrees. What is it here? Every what? Every pi, plus multiples of pi. So you know what? I can tell you right now the sine of 10 pi is 0. The sine of 11 pi is 0. The sine of 12 pi is 0. The sine of 1,000,000 pi is 0. The sine of 1,000,000,000,000 pi is 0. The sine of 1,000,000,001 pi is 0. Any multiple of pi is 0. Kind of nice. Let's go look at cosine. Says lesson 5 homework number 1. We're going to do cosine together ourselves. Only this time we have to change our calculators. Are we in degrees this time? How do I know I'm in radians? What did they tell me for the domain between 0 and what? And 2 pi. So let's go to our calculators and menu, shift, setup, down, 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 down. Radians. Put your calculator in radians, please. What's the cosine of 0? Question, Colin? No? Hey, what's the cosine of 0? 1. What's the cosine of pi over 6? Cos of bracket pi divided by 6. You have to put it in brackets. You get 0.87? Yeah? If you're not in radians, or you didn't use brackets, or you didn't hit cosine. What's the cosine of pi by 3? 0.5. What's the cosine of pi by 2? 0. What's the cosine of 2 pi by 3? 2 pi by 3. Negative 0.5? What's the cosine of 5 pi by 6? 5 pi by 6. Negative 0.87. Some of these numbers are looking a little familiar. Hey, what's the cosine of pi? Negative 1? I'm going to skip one. Don't do that one. What's the cosine of 4 pi by 3? Negative 0.5? What's the cosine of 3 pi by 2? 0? Cosine of 5 pi by 3. 0.5. Skip that one. What's the cosine of 2 pi? Oh. One. Scratch out the 0.87 and the 0.87. Let's just graph the rest of it because those are nicer points. So this graph goes through 0, 1. It goes through, pi by 3. Where the heck is, well, how many squares make up pi? Count on the graph. How many squares make up pi? Don't write that down. 6. So what's each square worth? How many squares make up pi? So what's each square worth? Don't decimalize. Isn't it that? 1/6 of pi? If 6 squares make up pi, 1 square is pi by 6. Don't worry about getting decimals. You've got to deal with fractions occasionally. Okay. 1 pi, don't write this down yet. 1 pi by 6, 2 pi by 6. That's pi by 3 right there. So at pi by 3, which is 2 squares, we are 0.5 high right there. What about at pi by 2? Half of pi? Dead center, we're at 0. What about 2 pi by 3? That's 4 squares. We're at negative 0.5. Oh, I went too far again. At pi, we're at negative 1. At 4 pi by 3, 1, 2, 3, 4 pi by 3 is right there. We're at negative 0.5 again. At 3 pi by 2, we're at 0. And if you're having trouble with the fractions, don't freak out. You'll get good at this. We're there. We're there. This graph looks like this. And it continues. It goes like this. In fact, it looks an awful lot like the sine shape. Goes up, goes down, goes up, goes down. It says, graph it on your calculator using radio mode and the following windows. So let's go into our graph menu. Delete the graph we have here. We got to change our view window. It wants our x min to be negative 2 pi. Oh, it decimalized it. I guess negative 2 pi is negative 6.28. My x max to be 3 pi. Scale pi divided by 6. I'll just type that in. Now, you'll notice, Justin, it decimalizes everything, but I've typed it in okay. Dot, I leave as 1. Question? I'm getting right from here. It's right in your notes. Use this window here. Okay? But the y ones I don't need to change. So change your view window. Cos x. And then hit draw. Jake, you get this okay? Jacob, you got that okay? Yeah. By the way, that looks an awful lot like sine, but kind of the same shape. This is why sine and cosine are very similar. Hey, let's answer some questions. You have the graph in front of you. What's the domain of cosine? Turns out, all reals. Just like sine. What's the range How low does cosine go? -1. Hey, how low did sine go? -1. How high does cosine go? How high did sine go? Are you telling me they have the same range? Well, that's convenient. Cool. You're not going to tell me that cosine has the same amplitude as sine, are you? How high does it go, Ellen? How low does it go? -1. Total distance is 2. You're not telling me that the amplitude is also 1, are you? Oh. Next thing you're going to tell me that they have the same period. They don't have the same wavelength, the same period, do they? Let's see. Let's see. From here to here was 2 pi. What's that in degrees? Oh, get out. Really? Period is really? So, Rachel, I'm arguing that for sine and for cosine, I think I could have just given you, for sine, that same chart right there, and it looks like it's the same for cosine. Now, what is different? The intercepts. Cosine doesn't start in the middle. Cosine starts up high at 1. See it? But look, 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 look. Look up, look up, look up, look up, look up. It does go top, middle, bottom, middle, top, middle, bottom, middle. It does do that. Where's the first x-intercept? Right there, which is at pi by 2, or in degrees, 90 degrees. And then, how far apart till the next x-intercept? Well, 6 squares. Jordan, what did you say 6 squares was worth?
Pi.
Oh. So, plus multiples of pi, or in, plus 180 degrees. You know what? It's the same pattern as for sine. It's every 180 degrees. It's just the first first x-intercept starts at 90. So cosine of 90 is 0. Cosine of 270 is 0. Add 180. Cosine of 270 and 180, 540 is 0. Cosine, I can figure it out. 540, 450 is 0. Sorry. Okay. Y-intercept, instead of 0, 0. Sorry, not 1 comma 0, 0 comma 1. Okay. Your homework to try with your graphing calculator. Number 4. Number 5. Number 6 in degrees. Try that. You have 25 minutes, the remainder of class.